Okay, before we get to this assignment here, we have some things to discuss about why we have to use the methods we use. Now, there's a couple little things we need to know. Taking an x squared divided by an x is always equal to just x, because it would be a 2 minus a 1, which is 1, but we don't usually put the 1 power on the x. X divided by x gives me a cancel. Okay, so you're going to write those things down. Now I want to throw this easy equation at you that we've solved since October or September. 3x plus 4 plus 5x equals 20. We have one answer to this problem. Okay. Alright, so there's two x's are on the same side, so you v those up, and it's 8x plus 4 equals 20. Then you got times 8 and plus 4, so you're going to minus the 4. 20 minus 4 is 16. Then you're going to divide each side by the 8. 16 divided by 8 is 2. Okay. Now, what I just applied there, and we didn't do this isn't anything new. That's a process. It's a term I haven't used. It's known as linear properties. And we didn't know that was a name for it, but that's what it's called, linear properties. Now, today you're not going to be able to use linear properties because you're going to have an x to the second, so there are actually going to be two answers. And you have an x to the second and an x to the first. X means x to the first. Well, those are not like terms, okay? An x to the second and x are totally different terms. It's not like here we have x and x. They cannot be combined. So you have to use what's called factoring properties or principles, okay? Now, let's talk about this. So we have 2x to the second power plus 8x equals 0. Now, this has two answers because your x is to the second power. Now, if it would, it's not going to come up today, but if it's x to the third power, there would be three answers. X to the fourth is 4, and so on, okay? Now, there's two answers because we have x to the second. Now, we've also got x to the first, just put x then. So these are totally different terms, so we have to apply factoring properties. Just write factoring. Now, when you use factoring properties, the first thing you need to make sure is that one side of the equals is 0, okay? And it is, so write the word set, okay? So that means we're good. So what we're going to do now is make that box that we used yesterday, okay, because that was the process, and that's all we're going to do. There's these two terms here, okay. For now, we have to factor the two terms into a P1, P2. So you make the line, and then the parentheses, and the equals 0 is going to go outside, okay. We're going to take this and rewrite it into a different form. Okay, so first thing you do, and you don't count the 0. The 0 is right there. You're only looking over here, okay? Do your letter check. You got a letter there, x. Do your negative check. You don't have ones. And then 2 and 8, okay? Go on your multiplication table. A lot of you, I would hope, know that that's 2, but no, 2 and 8 is 2, okay? So 2x is your GCF. GCF. Then you go up and divide by 2x. So 2 divided by 2 is 1. Now remember, x squared divided by x is x. So you need to place an x behind the 1. Then positive 8 divided by 2 is positive 4. And then x divided by x cancels. Now, what I've done is I've written this into a P1. So you just bring it over here. So go 2x times 1x, or x plus 4, equals 0. Now, this is P1, this is P2. So, now to solve it, you set each of your p's equal to 0. So 2x could equal 0, or 1x plus 4 could equal 0. Then you can apply your linear properties. So you got times 2 here, so you're going to divide by 2. And 0 divided by 2 is 0. So 0 is my first answer. Here, guys, if you have a times 1, I'd just get rid of the 1. You don't need that there. It's just plus 4. So minus 4, 0 minus 4 is negative 4. Because dividing by 1 just keeps it at the same. Okay. I mean, you can keep the 1 there if it makes you feel better, but it's really a waste of time. So So those are your two answers. Now, you check your answers into the equation, okay? 2 times, and I'll put 0 in for x, 0 to this caret 2 plus 8, and then times 0, because there's an x there. It should be equal to 0. It is. Okay, now click up, and instead of 0, put negative, well, you're going to have to clear it. So 2 times negative 4, okay? Sorry, if it's a negative, you got to put it in parentheses. You don't have to do this, okay? Caret 2 plus 8, okay? Times negative 4, 0 again. So that's why there's two different answers. Okay, next problem. 6x to the second power minus 15x equals 0. Okay, so there are two answers because you have x to the second. Now, not only do you have x second, you have x to the first. Those cannot be combined, so that tells me I have to use factoring principles. So factoring principles, first thing you got to do, circle your equals and make sure you have a 0 on the right side. On one of the sides, you do, you're set. So now you make your factoring GCF box and you push the equals 0 out, because all you're doing is taking this and rewriting it into a P1, P2. Okay, so check for your letter. It's there, it's x, okay? No negative. 6 and 15. Here's 6, there's no 15, here's 6, here's 15, so it's 3. Now you go up and divide by 3x. So 6 divided by 3 is 2. X squared divided by x is always x. Negative 15 divided by 3 is negative 5, so minus 5, and then the x's canceled there. Okay, so we have now rewritten it into a P1 times P2. And then we set each of our polynomial factors equal to 0. So 3x could equal 0, or 2x minus 5 could equal 0. So here I got times 3, I just need to divide by 3. 0 divided by 3 is 0. And over here we got a times 2 and a minus 5, so we have to add the 5, then divide by the 2. Okay, so 5 divided by 2 is a decimal. You can write 2.5. If you're going to go second PRB, 2.5. Okay. I'm fine with 2.5. I just don't want those decimals that go on forever and have to be rounded off. I want the exact answer. Okay, next part. Next page. 3x. You have to practice this to get good at it. 3x to the second minus 9x equals 0. So again, we know there's two answers. Okay. I want them right there. Because we have x to the second, but unfortunately we've also got x to the first, those cannot be combined, so we have to apply factoring principles. Okay, so we're at 0, so that's set. Okay, because you need the 0. You cannot solve this by what we're doing if you don't have 0, because you want to put an equal 0 outside of there. So GCF, you got x. Okay, you do not have your negative, okay, then 3 and 9 is just in 3. Okay, now we got P1, but we got to get P2 by dividing by that 3x, okay. So you're taking this up here and dividing both of these by 3x. So 3 divided by 1 is 3 divided by 3 is 1, okay. X second divided by x is always x. The negative 9 divided by 3 is negative 3. So I put minus 3. Okay. Then these cancel. Okay. So we've got 3x times 1x minus 3. And now I have my P1 and my P2. Okay, so 3x could equal 0. 1x minus 3 could equal 0. So you divide by 3 and you get 0. Guys, if you have a multiplier of 1, get rid of it, okay? You don't need that. If it's not a 1, you need to, but you don't need to be dividing by 1. X equals 3. So 0 and 3, it serves no purpose. Okay, next problem, negative 16x to the second power plus 80x equals 0. So again, two answers. Okay. And because we have x second, we've also got x to the first power. So so those are not like terms, so we cannot add those. We can't combine them in any way, shape, or form. So we have to apply factoring. Okay, so do you have your 0? Yes, you do. So you're set. That's going to change on the next problem, but for now we're good. So we underline the two terms. Okay, and we have to divide by the same thing. We divide both of these by the same thing, whatever the GCF value is. So x there, you bet. And you have a negative, so you need to also put a negative. So 16 and 80, 16, here's 80, so you get 16. Okay, so you divide by negative 16x. So we divide the negative 16 by the negative 16, that's positive 1. X to the second divided by x is always x. Then I take positive 80 and divide it by negative 16. I got negative 5, so that now is going to be written as a minus 5, and then these cancel. Now we're good. So negative 16x times 1x minus 5 equals 0. So now I have factored this into two separate polynomials. Okay. So negative 16x could equal 0, or 1x minus 5 could equal 0. So you have the multiplication by negative 16, so you don't have to add or subtract, you go straight to your dividing. So 0 divided by negative 16 is 0. And over here, guys, if you have a multiplication with 1, get rid of it. Minus 5 plus, now if it's addition or subtraction of 1, you don't get rid of it, but a times 1 is stupid to have. So x equals 5. 0 and 5. In case you haven't noticed, today's 0 is always one of the answers. That's going to change in the future, but for today. Now look at this. 14x to the second power equals 28x. So we have two answers. Now in the whole equation, we have x to the second, and we have x in there too. So we have to apply factoring principles, but you have a little problem at the start. You don't have your 0, okay? We want this to be a 0. So I'm going to get rid of the 28x. Since it's positive, to take that to a 0, you need to subtract 28x. But here's the deal. It can't be subtracted from the 14x squared. Now, so what you do, I'm not going to put a 0x because it clutters up the space, okay? What you do with that 28x is just put it after minus 28x after your 14x to the second. Now you write the equation so it looks nice. 14x to the second minus 28x equals 0. Now you're set, okay? So you're set. So now you're set to factor. Remember, to do this GCF, you got to be able to put equals 0. And if you can't, you got to take that to 0 by adding or subtracting. Remember, an x does not go with an x to the second. They need to remain separated. Okay, so variable check, I've got x. Remember, you're just looking at this side now that this is 0. Okay, no negative. Now look up 14, 28. So in the 14th row, 28's there, so it'd be 14. So now I go up and divide both of these by this term, 14x. Okay, 14 divided by 14 is 1. X second divided by x is always x. And then I take negative 28 divided by positive 14, which is negative 2. So I'll put minus 2, and then these cancel. Now I have factored in two separate polynomials. So P1, P2. So 14x equals 0, 1x minus 2 equals 0. So you're going to divide by 14, and that's 0. Okay, then get rid of the 1. You don't need times 1. You just plus 2, and you get 2. So 0 and 2 are the two answers to that equation. Okay, next problem. Negative 24x to the second power equals 9x. So before I start, I know the equation has two answers. There's an x to the second, and there's also an x to the first, so that means we have to apply factoring principles because those cannot be combined. But before you do factoring, you have to have 0 over here. So you're going to subtract 9x, but this is x to the second, so the minus 9x has to come behind that. So now I write negative 24x to the second power minus 9x equals 0. Now I can factor. So GCF, and then we go from there. So remember, I'm just looking at these two. I'm not looking at the 0. See, I've already placed the 0. I'm looking at the polynomial product there. Okay, so I have an x. You have a negative in front. Okay, so you need to put that 24 and 9. So here's 9. There's no 24. Here's 9, and there's 24. So it'd be 3. Now you go divide that, both of them, by negative 3x. So I take negative 24 divided by negative 3, that's positive 8, and then x squared divided, x to the second divided by x is always x. Then I take negative 9 divided by negative 3, that's positive 3. So because it's positive, we write it as plus 3. It's negative, you write it as minus. Then don't need those cancel. So now we're good, we're in the clear. So we have negative 3x times 8x plus 3 equals 0. So P1, P2. So negative 3x equals 0, 8x plus 3 equals 0. So you get times, so you're just going to divide by negative 3. So x equals 0. And over here you got times 8 plus 3, so minus 3, minus 3. 0 minus 3 is negative 3, and then we'll divide by 8. Don't second PRB that, so it would just stay negative 3/8. Okay. Next page, last page. I already did this one here. That's the same as the one I just did. Now let's look over here. 8x to the second equals 4x. So again, there's two answers. Okay. So because we have x to the second, and in that equation we've also got x to the first, we have to apply factoring properties. You can't combine them. Okay. So first we need a 0 to go here. So we're going to take out a 4x by subtracting it, but it can't be, that's an x squared. The 8's an x squared, so you got to put minus 4x behind it. So now rewrite it, 8x is second minus 4x equals 0. Now you're set up for factoring. To apply your factoring, put equals 0 outside. Check your x, it's there. No negative there. And then 8 and 4, so here's 4, here's 8, so it's just 4. So it's going to be P1. Now I go up and divide by my G, both of these by 4x. 8 divided by 4 is 2, x squared divided by x is x. Now, you don't just cancel it and put nothing, because you have to actually divide negative 4 by 4. Well, that's a negative 1, so you put minus 1. It's the x's that cancel. These don't cancel, it becomes 1. So, we've got 4x times 2x minus 1 equals 0. P1, P2. So 4x could equal 0, or 2x minus 1 could equal 0. So that's how we get the two answers. So we just divide by 4. 0 divided by 4 is 0. Now over here you got times 2 and minus 1. You can't get rid of the minus 1. You can only get rid of the 1 if it's times 1. So you have to add 1, and that's 1. Then you divide both sides by 2. And 1 divided by 2 is 0.5. You can put that, or you can just go with fractions, 1/2. And x equals 1/2, or 0.5 is fine too.